In the previous video, we have shown the digital output of the dual-band telemetry system. So in this video, we are going to show the analog signal at the intermediate stage. So let's take a snapshot and take a closer look into the signals. The yellow trace on top here is the transmitted data signal. The blue trace here is the transmitted power signal. Now they're in different scales. For the yellow signal, yellow trace, it's 10 volt per division. For the blue trace, it's 50 volts per division. So you can see they are driven both by Class E amplifiers. So the yellow trace does not only have the ups and downs of 20 megahertz carrier signal, but if you look very closely, there is a slight envelope associated with it, and that slight envelope certainly tracks the ups and downs of the power carrier signal. So here we're seeing an interference on the data signal by transmitting power and data at the same time. This will be more clear when we look at the received data signal, which is the purple trace here. Again, we not only see the ups and downs of the data signal, but also the associated power carrier interference. The magnitude of the data signal and the power carrier interference oftentimes are in the same order of magnitude, and in a lot of cases, depending on coupling coefficient, depending on how much power the telemetry system is designed to transmit, the signal-to-noise ratio can range from one place to another. In this case, they're almost the same. Signal and noise are almost the same. So this creates a task for the DPSK demodulator to process it later. The green trace underneath is actually the filtered version of the received data signal. In this telemetry, in this prototype, we create a small or low-order filter to filter out the high-frequency noise received from the data coil. Now these high-frequency noise are generated from different places. Some comes from the power supply, some comes from the scope, some comes from the wires running embedded in the building structure. And we're going to, so now we have shown the intermediate signal. There's one more interesting thing I want to show here. It's the sudden jolt that happens every so often. The reason we have these sudden jolts on the transmitted signal is that we create a transition edge on the PSK transmitter. By doing so, we're shifting the data carrier by the face of the data carrier by 180 degrees. You cannot see clearly on this scope right now because we didn't show the reference clock underneath. But if we do put the reference clock underneath, you will see that before the carrier signal, data carrier signal, before the sudden jolt and after the sudden jolt has a 180-degree phase shift. And this transition from phase 1 to phase 2 does not happen immediately at the point of the sudden jolt. It takes 2 to 3 cycles to complete. So in the next video, we've shown the output digital signal, the intermediate analog signal, and then in the next video, we're going to show the physical implementation of the telemetry link and the digital signal of the input.